Hi, everyone. Welcome to this session titled Dependabot Your Way to Zero CVEs with Copacetic. My name is Josh Dufty. I'm a senior cloud advocate here at Microsoft. And today I'm joined with Ashna. Ashna, would you take a moment to introduce yourself?
Yeah, my name is Ashna, and I'm a software engineer at Microsoft and a maintainer for Copa.
Awesome. All right. Well, I think today what I'll do is I'll start off with a story. So let me see if I I got the right key on my layout here. So I'll date myself a little bit. You can't see the gray hair with the hat. But my first job out of college was upgrading this company from Windows XP to Windows 7. And I just bring that up because I'm no, I guess, novice or beginner to Windows updates or updates in general. I spent a good bulk of my career, probably a decade, in system administration, and that entailed a lot of late nights RDPing into servers and updating and writing a bunch of automation with PowerShell for Windows servers and also doing some Linux updates as well. And one of the things that I was most excited about when containers came on the scene, or when I started using containers probably like 6 to 8 years ago, um, was the idea that I would no longer have to do updates. Um, didn't turn out to be the case because any kind of compute workload that is running for a long time is going to become vulnerable and you're going to have to do updates. So here on the left, you've got updates available. And then on the right, um, you don't necessarily have update reminders with containers, but if you use something like a scanner, or I'm sure your security team is going to be kind of shoving over scanning results to you, that's what you'll see on the right-hand side. So if we fast forward here, containers really didn't make vulnerabilities go away. Yes, you can update the base image, but we'll get into some reason why that's not always possible. But the long story short is we still have to deal with vulnerabilities, and we still have to deal with patching. And that's kind of where Copacetic goes in. So just hang with me and we'll get to that. So before I go into kind of the solution that we have for you today in the demo, I want to talk about some reasons why you might want to patch containers. When I first started using Copacetic, that was the very first question I had, and then also one that I think we've actually gotten in the Slack channel, or at least I've gotten at user groups that I've presented at, which is, well, why would you even patch a container? You could just update the base image and then vulnerabilities would go away, which is sometimes true, but there's sometimes the latest versions of a container that are still vulnerable. But there's some other reasons. The other reasons might be like you actually can't recreate the container. You've lost the build context, or it's a third party that you're dependent on. You're dependent on their release cycle coming down. And so your security team says, hey, this needs to be fixed before. We can't just waiting on the vendor isn't a good enough answer for us. So we need a different solution. There could be a high cost and delay if you're familiar with change control boards. Getting a base layer reapproved that is a whole pipeline change for your code base. It might be too much effort to stay on top of CVEs. And then there's some operational risk when, okay, we are doing a new release of our container image because there's a vulnerability, but what code changes is being pulled into that? And is that going to, if increasing that release cycle, is that going to make us more vulnerable, or does that inject more risk into the system? And so there's just some like high level ways of why you'd want to maybe consider patching a container. Do you have anything to add, Ashna?
I think those were pretty good reasons. Yeah, and I think like one of the goals with Copa is to make this process easier and quicker. And yeah, we can get into that next.
Yeah. So next, I'll hand it over to you.
Yeah, so the way Copa works is it's a CLI tool. So if you look at the diagram on the left, that represents a image with the different layers, the OS layer, language, framework, and application layers. And Copa targets the OS vulnerabilities. So you can generate a scan report using a scanner like Trivy. And once you pass that into Copa, Copa parses that report to find the outdated packages. And then using the default package managers, it'll apply the updated packages as a diff with the file system bundle. And then on the right, you can see the patched layer in a resulting image. So this would be a new patched image with all the vulnerabilities that Copa found from the report resolved. And we try to make Copa like pluggable with different scanners, so you don't have to use Trivy to generate this report. You can create plugins, like we have a Gripe plugin and other scanner plugins that are being developed. And you can also omit the scanner completely, and then Copa finds all the outdated packages in the image and then creates the patch layer using that.
I think you definitely did. So, or answer this question. So one of the questions that I got previously was, what exactly do you mean by patching in this instance? And you touched on it, which is OS level packages or dependencies that your application might have. That is what we're talking about here. We'll be able to patch those. Application one, we'll have to see in the future what holds there. But for now, what Copa does is it looks at the OS packages. And one thing just to note there is your application might not be dependent at all on any of those packages that are vulnerable. But if you just grab, say, like a Ubuntu image and you don't do any kind of fine tuning to reduce your image or to use a lighter weight container image as your base, there's probably a ton of vulnerabilities just sitting in there because of the image that you picked, not anything that your application actually needs.
Yeah, and another thing Copa can do is it can patch distroless images. So if the package manager isn't in the image itself, Copa uses a tooling image to download and apply the updates, which is something you wouldn't be able to do if you wanted to do that manually.
That's interesting. I didn't even know Copa said it could do that. That's super cool. So like say I was using like from scratch or something where it just has the file system but I have like one package that I need, it would be able to figure out how to update that dependency.
Yeah, so if it had a specific package, it would use so it would get the tooling from a separate image and then it would use that to perform the downloads.
Nice. And then add the patch layer.
Mm-hmm.
That's cool. I had no idea I did that. So thanks for sharing that. All right. Well, without further ado, let's take a look at what the overview. So there's quite a bit going on in here. And so I kind of want to set the stage for two parts of the demo that we'll walk through. The first part is the continuous patching. And my first demo here will kind of tee this up, but I want to give you at least the landscape, right? So the continuous patching would be, maybe you can add some context to this in a minute about like how this came about inside Microsoft and how we do the registry patching where we're continually scanning and patching those things. But this on the left side here, this continuous patching, which is get images from the registry, scan the images for vulnerabilities, patch them, and push a new patch. So that's one potential way to use Kipacetic, right?
Yeah.
Okay. And why you'd want to do that. So in my mind, I was like, okay, well, if I go back and I put my platform engineering hat or my S3 hat on, which is what I've been prior to Microsoft, I probably wouldn't want to sit here at the command line and like one by one run whatever it is. So like patch this image and then push this one. I'm going to write some kind of automated task or system that's going to do all this for me. And so that's what the continuous patching does that we'll dive into here. And I've used GitHub workflows to accomplish this, but there's a variety of ways you could do. So that's what that'll do. You just point at a registry. It's going to use Trivy to scan, and then it will patch the image and then push it up. And then so the next natural question is, okay, well, that's fantastic. I have patched images on my registry, but that doesn't mean that I'm any less vulnerable in production. So that's where the Dependabot comes in. So we can use Dependabot to look at the Docker files of a particular repository and check to see if there are any updates. Now, there are some requirements here, or at least constraints, where your container image needs to be SIMVER compliant. That way, Dependabot can actually handle the diff between what's new and what's old. But it's pretty simple. You just add a little configuration to your repository, and it will look for that. Look at your registry and say, oh, there's a -1 or a -2 for a patched image. We'll go into all those semantics in the demo. And then it'll open a PR to it. And so then that'll kick off a whole release cycle. But from the platform engineering side, it's like, oh, my job's done. I've patched images. I've made them available. Now it's back over to the other side of the fence to say, hey, we've got a new image that's less vulnerable. Let's put that in the pipeline. And I accidentally hit a key. So we'll skip that part. We'll go right into the demos now. Accidentally closed out of the slides too soon, but that's okay. So let's take a look first. I want to get people familiar with copacetic and at least just show off some stuff. So I've got a little demo here just to show how it can remove the vulnerabilities. So I whipped up a demo magic script, which I think is this demo. And I think it's .sh. Yep. So I'm just going to kick this off, and it's going to walk through what this looks like every time it's going to go through that continuous patching cycle. So all I did here was I picked an image from my GHCR instance. Scroll, just to show that it has a lot of vulnerabilities. This is an image that a colleague of mine, Paul, used for the Azure voting app. There's a lot. Maybe too many for the resolution that I have. Okay, we'll just say that there's a lot of vulnerabilities because I can't scroll the buffer enough to list them all. So we'll move on. So essentially, Trivy is going to show me all the vulnerabilities. I'm going to output that to reports JSON that copacetic can ingest. And that's that report JSON I said there. And I'm going to name it. So the -t there is going to give the new container image a name. So it's going to be the previous tag -patched. And so this will go through and do just what we were talking about earlier. Well, it'll take the results, find the package, patch it. Almost done. 30 seconds maybe. There we go. And then I'm going to rescan the image to show that the patched one doesn't have those vulnerabilities anymore. And now I don't have an infinite buffer, and it immediately tells me I have 0. So that just shows you what copacetic's doing every time that it runs. But now let's go take a look at the workflow where we can see this kind of in a solution kind of put all together. So this is the continuous patching repository. It's just under my handle that I put together. It is a template, so if you care to use it, you can just clone it. And then the steps to recreate it, you're going to need a personal access token to be able to talk to your registry, so forth, because it does need rewrite. So your default actor token is not going to work in your workflow. But all those steps are documented there, and a review of, I guess, more in-depth review of the previous slide that you saw. But let's take a look at the workflow quick, because there's a little bit of glue code that I had to write to get this to work. But if we start at the beginning, I have it on demand for the sake of demo. But what you'd ideally want to do is to put it on a cron trigger. This one here that's commented out would be like 4:45 every morning. It's going to kick off, and it's going to run through and patch all your images for you. But there's kind of 2 jobs set up in this that we want to think about. The first one really sets up everything, and it gets all the images. So the first question that we have to answer is, what tags do I need to patch? Or what are the images and what are the tags that I need to patch? So we need some kind of a tool to do that. If you only have a few, you can actually just define a matrix in your file. And if you want to see an example of that, I have another repo called Secure Supply Chain on AKS, which I put together for build 2 years ago now. It's been a minute. But if you look at the workflow, it's just the patch one. This is what it would look like if you knew your images and you wanted to pass them into a matrix. And the matrix is what creates all the different jobs we'll see in a second. But we need something that populates this list. We need something that can create the matrix for us. So I took it upon myself to do my favorite thing, which is to write a CLI and create a GitHub action for it, which just seems to be a task that defines me. I can't remember the famous individuals whose quote this came from, but the definition of a system is what it does. Have you heard that one before?
I haven't.
Okay. So if you look at any kind of computer system, you don't really need a definition. You just look at what it does. Well, applied to humans, Josh's purpose and definition is write CLIs and create GitHub actions. That's what I do. So I did that. And I created this, I thought it was rather clever, contiguous
Yes, I like that.
But essentially all this does is it only supports GHCR right now, but hopefully I'll get to ACR eventually. But it'll just connect. It actually uses your Docker token, so you don't have to, if you're already logged into GHCR through Docker, it'll use that token to query. But it just goes and it's got some different logic to also generate the incremental tag. So do you want to take a minute and talk about the tagging strategies with patch images before we go on? Like what's incremental tagging, and is there another option for how do we tag these patch images? Should we just always append -patched, or how should we handle that?
So yeah, usually if you're just testing out Copa, doing a -patched is fine, and that's what Copa does by default. But for if you're using it with like Dependabot or something else, it's usually better to do incremental patching. So like .1 or -1, -2 for the second patch, -3, going on forward with
Okay.
that.
That makes sense. So I read the docs, so that's all documented on the Copacetic website if you want more information, which is, let's just find it. We got time. We'll show off the web page real quick. So if we go to projectcopacetic.github.io, tagging guidelines right here. Static incremental tags is what we're talking about.
Mm-hmm.
So there you go. All right, back to the workflow. Anyway, so yeah, this little CLI and this whole step here is going to look at my registry and then find out which images need to be patched, and then also return to me what the next incremental tag should be. So it figures all that out for me. And you can check out my GitHub if you want to see that. You could also just download it and test it locally, which maybe we'll do here in a minute. And then I actually have it displayed out just so we could see it. So now that we've got all the images, it's time to go through the patching loop, or the patch job, I think is the proper term in a workflow. And it's not too bad. I'm going to set up the matrix from this. So essentially what that says, for every entry in this matrix, you're going to do this entire job, this patch job. And it starts by generating the Trivy report, which we saw previously. And so I'm passing in the image name for that. And I'm saying, output a report JSON, so Copacetic can do that. And then I'm using this here to check the vulnerability count. That's just so I can skip Copacetic, because if there aren't any vulnerabilities found, there's no reason to call that particular step inside the action or the job. So I'm just going to skip, and so that allows me to do that.
And yeah, Copa would fail if there aren't vulnerabilities to patch.
Yep.
So we don't create an exactly same patched image.
Right. So that would create a false positive or positive false. I don't know how that flips, right? Like it failed, but it actually is fine. That's a false positive. Yeah. Okay. There we go. Let's see here. Yes. And then there's the Copacetic action. So this is a good call out that Copacetic is a CLI, but it does have a GitHub action that you can use in your workflows. So that's what I'm calling here. And then I'm feeding it in the report JSON. And then I've already pre-calculated what the patch tag is going to be from the contiguous up above. And so that returns a hash table with 2 values in it. So it's going to have the current name and then what the next incremental tag name will be. So I'm passing that in here. And then super simple, logging into the registry and then pushing the image, and kind of go from there. So let's just see this in action. So if we look at my packages, and that's bright. I thought I switched to dark mode. There we go. Much better. The ones that I'm really worried about are the Rust and Debian. Those are used in the ones that have the Dependabot thing that'll come up here in a second. So if we look at Rust, I have this 179.0, and there's quite a bit of vulnerabilities in that. And then there's the Debian. So what I want is this whole workflow to go through and patch this on a nightly basis, and then I can have Dependabot go and update my code repos, is the gist. So let's just go ahead and kick it off manually so we can see it in action. So continuous patching. We'll run it across against the main branch. So here's the setup where it's going to go and figure out all the images I need. And while we wait, are there any other interesting ways people have kind of plugged copacetic into different things? Or what other integration points does copacetic have other than the CLI? That's probably a better question.
So we have the GitHub Action, like we're showing here, and we also have it as a ACR task internally. And then we have a lot of the contributions have been like scanner plugins, like a Gripe plugin to be able to use Gripe reports with Copa. And yeah, it's also been integrated in some projects in the open source community, like Helper, and a few other. I think they're listed on the website.
There's also, there's a Docker extension, right?
Yes, there's a Docker extension to use it locally, so you don't have to download Copa or worry about any of the setup. You can just use it directly in Docker Desktop on the images you have.
I think it has Kubescape.
Yes, we also
integrated. Okay, I was browsing their code base the other day, and I was like, I think I know what this is. That's fantastic. All right, so we've got the two main ones we're going through, but if we look at like net monitor, looks like it skipped it because it was already patched, which is cool. So let's go back here. I kind of like seeing this view if we expand jobs. If it lets me, there it goes. So however, if you've got like 1,000 images, this is going to be super long, but I've only got a few. So let's just pick on Rust and see what it's doing. Still patching. Nice. And then, oh, Debian finished. So let's go look at packages. Look at all the versions. Oh, I'm on Rust. That's why I don't see it. Debian. There we go. We've got our -1. So that completes the first part. We've got a workflow pushing patched images. That's fantastic. But how do we actually get our production workloads to not have vulnerabilities in them? And that's where the copacetic went into, or the Dependabot comes in. So this is actually just cloned from or forked from the Dependabot example. And I just shoved in some old code from an Azure voting app that I used a while back that was rewritten in Rust. And really the only thing you need to add to get this to work is this Dependabot file right here. Because it is on, or at least the images I'm using are on GHCR, I have to treat it as if it's a private repo, even though it's public, because it needs to have a token. So just like the other workflow, you're going to need settings in here for a PAT token for Dependabot, which is under your settings, and then Dependabot, well, I can probably show you. So if we go to security and variables, it's Dependabot here. It's going to need a token. But if we go back, this is all you need as far as configuration, which is defining the interval, what type of ecosystem it is, because it's Docker, and then the URLs here, right? So here's where the token comes in. But then after that, if we look at, I don't think this will trigger yet, but let's see if we can. Dependabot. Where's the scan? That's an alert for the, that's not what I'm looking for. Our policy. Oh, yes, advanced security. No, I was trying to find the tab where you can, maybe it's in insights. No, where you can trigger Dependabot. Let's see here. Dependabot, view Dependabot alerts. Oh, it's probably in here. Refresh Dependabot alerts. There we go. Sorry, that took me a minute. So I've got it scheduled at a particular time once a day, but this should go through. However, because the tags are the same, well, actually they're not. They should show up here momentarily. But as you can see, Dependabot found that there was a different one. It should close out these PRs because I went through and deleted. I reran this a bunch to test, essentially, is what I did, right? And so in that, over a couple days, there was more vulnerabilities found. So it created like a -2, a -3, -4, as you see here. But all those are gone now. So Dependabot should be able to close out these PRs, and probably not while we're recording because it does take a little while for those background things to finish. I should see 2 more PRs open with -1 for both Rust and Debian. And that's actually being used, forgive me, I forgot to show you, in the Docker file here. So this was defined in the Dependabot. It said, here's your Docker file, where's the path? But right here is where I'm using these images. One is a builder image, and then one is the image that it's used to run. But these should both be replaced now with the previous tag and then the incremental tag of -1 for each of them. Now, if there was this stayed static and I don't change these base images, I will go to a -2 or -2, -3 over time as more vulnerabilities are patched. I was hoping if I just hit refresh enough that Dependabot will catch on, but I don't think it. I think it's going to. One question before we wrap up, and I don't know if you know the answer, but if we look at this here, so here's the contiguous one, and I'm just going to run it so you can see like how the matrix was generated. But one question I had for you was, what do people do with these minor versions? Do you patch every minor version, or do you, like, how does that go? You see, like, I have 0.11, 0.10. Is there any guidance on like what version should you patch, like major or minor? It probably depends on how you're consuming the images, right?
Yeah, so I think we would recommend patching the minor version, and then Copa takes those that base image and applies the update. So when we are using the tagging intervals, you can just simply replace the one you had before with the new tag.
Gotcha. Okay, that's good to know. Thank you. That was more a question on my end that I just ran across. So, but with that, that's kind of the end of the demo. This is a kind of a solution you can start to build up and, depend about your way to 0 CVEs. So I hope everyone that's watching found that at least useful. And I hope that they bring some comfort in knowing that you no longer have to, or at least you don't have to patch these manually. Like, I was dreading the day of like, please don't make me like log into a cluster and do updates like I used to do Windows updates. I don't want to go back to that world. And so I was very relieved when I found Copacetic and found a way to automate a lot of that stuff. But without further ado, let's kind of hit up the last couple slides, and then we can kind of go from there.
Yeah, so to close off, we just wanted to share some upcoming features for Copa, and these are mostly focused on improving like the user experience of using it. So one thing we have coming up in the next release is multi-architecture support. So instead of having to scan and patch an image for each architecture, you could just supply the manifest and have Copa patch that as a whole. We also are adding a push flag, so you can push directly to the registry when Copa patches the image. And finally, we had Docker support before, but we also wanted to add OCI support as well.
Awesome. I'm really excited about the pushing part of it. That removes a whole bunch of stuff that I have to just that I have to add in there. Another Docker login, all these other things. And then the OCI, I'm curious how that'll play out over time with the OCI support, because I know more and more things are getting shoved into OCI artifacts. One of them being AI models, amongst other things. And then WASM components, WebAssembly components that I've dabbled with too. But enough of that, enough of me chatting. For those that want to learn more or get involved, there's a couple ways that we'd recommend. The first one is Slack. This is where we're the most active. So there is a copacetic channel on the CNCF Slack. We will be doing, I think we're starting up really soon, the community calls again, which is fantastic. And a great place just to connect with maintainers such as Ashna here. And then there is a mailing list, right? And so that'll be mainly for just notifications for releases and security announcements. With that, thank you for joining us. I hope that you found this informative. And Ashna, thank you so much for joining me.
Well, thank you for having me.